So in the last two parts, we've talked about how to find the value of A and also how to find the value of B. Today we're going to use the values of A and B to actually write an exponential function. So part 3 says how to write an exponential function after you have figured out the values of A and B. So exponential functions all have the same setup. They were always written as f of x equals a times b to the x power. What this means is a is like your starting place, and b is what you multiply by x times. So for example, if this is a times b to the third power, if x is 3, then it would be a times b times b times b. This is the constant multiplier. It's what you multiply by over and over and over, however many times x is. So this would be a times b to the first power, a times b to the second, a times b to the third, times b to the fourth, and so on, each time you multiply it again. So the x is really however many times you're multiplying it by. This is where you're starting, and then this is what you're multiplying by each time over here. So if you look back at page 2 of your notes, you'll notice that these three tables and these three graphs are the exact same 6 functions as these three tables and these three graphs in part 1, and these three tables and these three graphs in part 2. So what we're going to do is we're going to skip figuring out what A and B are over here in part 3 because we've already done that. If you look back at part A, you can see that in this first table, A is 1. In the second table, A is 3. In the third table, A is 1/2. And I'm not going to spend time on that because we've already talked about that over here. In the graph, A is the y-intercept, so we're looking at 2, 1, and 3. Now we can say the same for the b values. We've already found the values of b for each of these functions in part 2. And so I'm just going to write them over here so we can have them again. And if you are confused about how I found those b values, make sure that you either ask me or go back and watch part 2 of the notes again, and that will refresh your memory. But in the meantime, looking back at that page, it says that b is 2 right here because it's multiplying by 2 each time. We have this multiplier of 2 going down. B is 0.5 because it's multiplying by 0.5 going down. B is 3 because we're multiplying by 3 going down. Here we found several points on our graph and then made a table, and we learned that B was 5, 3, and 2. Now that we have all of our values of A and B, we can use those to write the function. And we simply do that by putting A here and B here to the x power. So for this one, our function would be 1 times 2 to the x power. And if we wanted to, we didn't actually have to write the 1. We could also say just 2 to the x power, since A is 1 and 1 times anything is just whatever that anything is. For the next one, it would be f of x equals 3 times 0.5 to the x power, and f of x equals 1/2 times 3 to the x power. So we're just taking our value of A, which is our starting place, our value of B, which is the constant multiplier, and plugging them into our function where A and B go, our starting place, and then what we multiplied the starting by over and over and over. Down here, same thing. We have our value of A times our value of B, and we're going to multiply 2 by 5, however many times x says to. Here we have f of x equals 1 times 3 to the x power, or because a is just 1, we could also write just 3 to the x power, because a 1 times 3 is really just 3 to the x power. And then over here we have f of x equals 3 times 2 to the x power. And that is how you write an exponential function. You take the value of a, the value of b, and then always just plug them into the same format. F of x equals a times b to the x power. And that is all for part 3.